Welcome back everyone. In the last video, we looked at an overview of Slack for IPv6. In this video, we are going to concentrate on stateless and stateful DHCP version 6. Let's do a little bit of a review. To get the dynamic GUA assignment, you can either go stateless or stateful. In stateless, that is Slack only, where every information of the addressing is received from the router advertisement, or we can have stateless DHCP, where it uses a DHCP server with Slack, or we can use stateful DHCP version 6. So in DHCP version 6 operations, these are the steps that they follow. Okay, so here, regardless whether it is stateless or stateful DHCP version 6, when the PC comes into the network, it will send a router solicitation message to the router. So the router then replies with the router advertisement. Receiving this router advertisement, because this advertisement will tell the device to go and seek the DHCP server. Then the device would then send a solicit message to the DHCP version 6 servers. Then the server will respond with an advertised message. The host then responds to the server, and then now the device would have an IP address. So let's look at stateless DHCP version 6 operation. If the RA indicates a stateless DHCP version 6 method, the host uses the information in the router advertisement message for addressing, and then contacts the DHCP version 6 server for additional information. So in this case, DHCP version 6 server only provides configuration parameters for the client and does not maintain a list of IP version 6 address bindings. Hence, it is stateless. So let's look at this example. After the PC sends solicitation to the router will send the router advertisement message to the PC. Within the router advertisement message, these are the information in it. It would have the IP version 6 GUA network prefix and the prefix length. It would set the A flag as 1, informing that the host must use Slack. It would set the O flag as 1, meaning that you have to use the information from the advertisement, but you also have to get additional information from the DHCP server, and the M flag is set to 0. So after receiving this advertisement from the router, the PC sends a solicit message to the DHCP server to get the additional information. To enable stateless DHCP version 6 on an interface, you have to use the command IP version 6 and the other config flag. So once you do this and you go into the interface, you will find that it says host use stateless autoconfig for addresses, host use DHCP to obtain other configuration. In a stateful DHCP version 6 operation, the router advertisement indicates the stateful DHCP version 6 method, and the host contacts the DHCP server for all configuration information. So in this case, the DHCP server is stateful as it maintains the list of IP version 6 address bindings. Again, same things happen. When the PC comes into the network, it would send a solicit message to the router. The router then sends an RA to the PC. So within the RA, we would have the IP version 6 GUA network prefix and prefix length. The A flag is set to 0. The O flag is set to 0. And the M flag is set to 1. So after receiving this router advertisement message, the PC then sends a solicit message to the DHCP version 6 server to get information. To enable stateful DHCP version 6 on an interface, you use the command IP version 6 and the manage config flag. This would set the M flag to 1. And if you check within the interface, you would see it says host use DHCP to obtain routable address. So let's look at how we can configure the DHCP version 6 server. Cisco iOS routers are powerful devices, and in smaller networks, you do not have to have a separate DHCP server. The router can become the DHCP server. A Cisco iOS router can be configured to provide DHCP version 6 server services. Specifically, it can be configured to be one of the following. It can be a DHCP version 6 server, which provides stateless or stateful DHCP version 6 services. It can be a DHCP version 6 client, where the router interface will acquire an IP version 6 IP configuration from the DHCP version 6 server. Or it can be a relay agent, where the router provides DHCP version 6 forwarding services when the client and the server are located on different networks. Let's look at the configuration of a stateless DHCP version 6 server. So there are 5 steps to configure and verify a router as a stateless DHCP version 6 server. First, you have to enable IP version 6 routing. You do this with the IP version 6 unicast routing command. Secondly, you have to define a DHCP version 6 pool name. Because you want to use this pool, the first thing you do is give the pool a name. After you have given the pool a name, you have to configure its options. So here, you might configure options such as the DNS server or the domain name. Once you have done that, now you want to bind the interface to the pool. Here, the router interface that will be handling the request from devices for IP addresses will be bound to the pool. Once we have done that, we can verify that the hosts have received IP version 6 addressing. So let's look at how this is done. So this is the topology we are using. We have 2 routers here. Router 1 is the server, router 3 is the client, and we have a PC here. So for now, we are going to configure router 1 to be a stateless DHCP version 6 server. So step 1, enable IP version 6 routing. We go into our R1 configuration mode and type IP version 6 unicast routing. After that, we have to define a DHCP version 6 pool name. So IP version 6, DHCP pool, and this is the name that is given for that pool, IP version 6 stateless. Now that we have done that, we have to now configure the options for the pool. So here the options are DNS server, we give the address for the DNS server, and then we also configure the domain name. So that's done. Step 4, we now have to bind the interface to the pool. So in this case, this interface G001, is going to be the one handling this DHCP information from the side. So we bind that pool to this interface. So interface gigabit Ethernet 001, you can put in a description, and then IP version 6 address. We have to set the IP version 6 address and the link local address. So link local address, IP version 6 address for that particular interface. Set it to be other config flag, meaning that we are now setting the O flag to 1 and A flag to 1. We set that for any device wanting or acquiring an IP, they will get it from this pool. And then don't forget to activate the interface. Once we have done that, PC1 would solicit, and then R1 will send an RA to PC1, and then PC1 would then connect to the DHCP server as well to get information about DNS server and also the domain name. Now we can verify that the host PC1 has received the IP version 6 addressing information. So ipconfig all, we can see it has the DNS suffix, it has the IP version 6 address, it has the link local address, and then it also has the DNS server. PC1 now has all the information and can continue to use the network. Okay, now we are going to look at how to configure the router to be a stateless DHCP version 6 client. Okay, now the client, what it does is that it will ask the server for an IP address, much like the device, much like PC1 just now. So the steps to get an IP address is 1, to enable IP version 6 routing, 2, to configure the client router to create a link local address, 3, to configure the client router to use Slack, 4. Verify that the client router is assigned a GUA. And 5. Verify that the client router received other necessary DHCP information like DNS server and also the domain name. Here again the topology, but right now we are going to configure R3 to be the client, and R3 will request from R1 to get an IP version 6 address. So first, enable the IP version 6 routing, IP version 6 unicast routing. Configure the client router to create a linked local address. So here, when we do interface G001, this interface here, and IP version 6 enable, it will create a linked local address within the same subnet as this interface here. Configure the client router to use Slack, IP version 6 address autoconfig. Remember, in a stateless DHCP version 6, the client must use Slack as well. So in the client, we have to configure to use Slack. So IP version 6 address autoconfig. So with these three things done, the client will now receive a GUA. So let's verify whether the client actually is assigned a GUA. If you look at show IP version 6 interface brief, it will show that interface G001, yep, we have a linked local address and we have a GUA. Then we can also verify that the client router has received other DHCP version 6 information. So you can see here the DNS server is there and the domain name is also there. So it's very easy, it's very straightforward, and it's done. Now let's look at how to configure a stateful DHCP version 6 server. So the stateful DHCP server option requires that the IP version 6 enabled router tells the host to contact the DHCP server to obtain all necessary IP version 6 network addressing information. So there are 5 steps to configure and verify a stateful DHCP version 6 server. So first is enable IP version 6 routing. You would see now that whether it is a client or it is a server, this command must be done. Then you define the pool. You have to give the pool a name. Then you have to configure the pool with its options, with its DNS server, IP addresses, and more. And then you have to bind the interface to the pool. This is the interface of the router. And then you have to verify that the host have received the IP version 6 addressing. So again, the same topology, but now R1 will become a stateful DHCP version 6 server. First step, enable IP version 6 routing, IP version 6 unicast routing. Second step, give the pool a name, IP version 6 DHCP pool, IP version 6 stateful. So this is the pool name. Once you have given the pool a name, you have to configure the options for the pool. So what is the address prefix? This is the address prefix, meaning that all the addresses assigned to devices asking for the IP will be taken from this pool. They would also get this address for the DNS server and this domain name. Once you have configured the pool, you have to bind the pool to the interface. Interface G001, give it a description, configure the link local address and the GUA for the link, and then set it to manage. In this command, it will set the M flag to 1, and then A flag and O flag will be 0. And then ND prefix default no autoconfig, there's no Slack because we are not using Slack. IP DHCP server IP version 6 stateful. So if any devices is asking for an IP address, the IP address will be taken from this pool. And then of course, activate the interface. So let's verify whether the host received an IP version 6 addressing information. So go again to PC1 IP config all, and we see that yes, it received the link local address, it received the IP version 6 address, okay, it received the DNS server address, and it received all information. So how do we configure a router to be a stateful DHCP version 6 client? Again, clients are the ones who's asking a server for an IP version 6 address. There are 5 steps to configure this. first enable the IP version 6 routing, then configure the client router to create the linked local address, configure the client router to use DHCP version 6, and then verify that the client router is assigned a GUA, and also verify that the client router receives other necessary information such as the DNS and the domain name. So again, the same topology, we are going to configure this client to be a stateful DHCP version 6 client. So first step, enable IP version 6 routing. Second step, configure the client router to create a linked local address. So interface D001, IP version 6 enable. So step 3, configure the client router to use DHCP version 6. So the router here, it will use this command to configure the router to be a client and use DHCP version 6. And then step 4, we can verify that the client router is assigned a GUA using the command show IP version 6 interface brief. So you can see this interface D001, it actually has a linked local address and also an IP version 6 address. Further, we can verify that the client router receives the other DHCP version 6 information such as the domain name and the DNS server. Let's look at how we can verify the configurations that we have done. The show IP version 6 DHCP pool command verifies the name of the DHCP pool and its parameters. The command also identifies the number of active clients. So here in R1, which is the server, show IP version 6 DHCP pool, we can see, yep, we have a pool. The pool name is IP version 6 stateful. And then the address allocation prefix is this. Okay, there are 2 in use right now, so there are 2 clients. And then DNS server is this, domain name is this. The show IP version 6 DHCP binding command displays the IP version 6 linked local address of the client and the global unicast address assigned by the server. This information is maintained by a stateful DHCP version 6 server. A stateless DHCP version 6 server would not maintain this information. So if you look at R1 and type show IP version 6 DHCP binding, we will see the client. There are 2 clients. The first client, this is the linked local address. This is the IP address assigned to it and when it will expire. And then the second client, this is the linked local address of the second client. This is the IP address assigned to the second client. So let's look at how we can configure a DHCP version 6 relay agent. If the DHCP version 6 server is located on a different network than the client, then the IP version 6 router can be configured as a DHCP version 6 relay agent. Now, why do we need a relay agent? A router does not forward broadcast. So this client here, when it broadcasts to the network to ask information from the DHCP server, that broadcast, it will not reach the DHCP server because it is in a different network. So this router in the middle has to play the relay agent. If you say, oh, you are broadcasting for DHCP, I will forward it. So how do we configure this router to be a relay agent? The configuration of a DHCP version 6 relay agent is similar to the configuration of an IP version 4 router as a DHCP version 4 relay. This command is configured on the interface facing the DHCP version 6 clients. It specifies the DHCP server address and also the egress interface to reach the server. Okay, let's look at an example. R1, interface gigabit Ethernet 001. We have to configure the command for relay agent on the interface facing the client. In interface G001, we type IP version 6 DHCP relay, destination, the DHCP server address, and the interface that goes out to the DHCP server, which is this interface. Okay, configure this command on the interface coming in from the client, and then within the command, set the interface going out to the server. So let's verify this. You can verify that the DHCP version 6 relay agent is operational using the Show IP version 6 DHCP interface. So you will find Gigabit Ethernet 001 is in relay mode, and the relay destination, and also how to get to that relay destination, which is the DHCP server. You can also check that the binding happens, and we check this in R3, which is the server, and we see that yes, we have a client and we have assigned the client an IP address. You can also verify the client itself, whether it is a PC or a router, and then check whether or not it has been given or assigned an IP version 6 address. So that is the end of today's lesson, which is DHCP version 6, stateless and stateful. We have looked at how to configure a Cisco router to be the DHCP version 6 server, to be the DHCP version 6 client, and also to be the relay agent. So until the next lesson, goodbye.